Hey Rick, how are you doing?
Hey Zam, how are you?
Yeah, pretty good. All right, let's see. Let me share my screen. Okay. All right, let's first start with questions. Any question related to the material that you're studying? I think you're muted, maybe.
Sorry, forgot.
Okay.
No, everything that we went over yesterday seemed pretty straightforward, and then I'm just doing all the sequel stuff now.
Okay. All right, good, good, good. All right. So today, let's see. Today we are going to be studying another kind of classification. Yesterday, we learned about logistic regression, which is one way of classifying it's a cat or a dog. And today, we'll be learning about something called K nearest neighbors or neighbor. So we'll be learning about that. But first, let's see that what we will be classifying and what or how does the K nearest neighbor actually works. So if I go back over here, we can see these flowers. All flowers over here that you see are iris, but they are classified differently. I mean, they are all iris flowers, as you can see over here, but they are different category. Their category is different because of the length of the petal and the length of the sepal. So that determines what classification they will have, setosa, versicolor, or virginica. And you can see over here, if you just search for iris flower, it will give you a little bit more information of what classify as setosa, the petal width and length not greater than 0.6 centimeter and 2 centimeter. Iris versicolor has a petal width different, and then the virginica also has different. So even though all of these flowers are iris flowers, they are categorized differently based on the width of their petal and width and length of their petal and width of their sepal. So how can we use some sort of an algorithm if somebody gives us these flowers, which is a good thing because in scikit-learn, just like the Boston data set, which apparently didn't work, just like the load digit data set, which worked yesterday, we have a load iris data set that will give you all the flowers for iris, only iris flowers. So you can play around with it. But before we do that, what is K nearest neighbor and how can we use it? So if I draw, let me see if I can draw it straight. There we go. If I draw this graph, and in this graph, let me drag this somewhere. Let's say that we are training for iris and based on the length of their sepal, or yeah, length, the width of their sepal and the length of their petal, um, we put some points over here. So this can be like the sepal length or sepal width, this one. And this can be the other length, uh, which is, let me actually, I keep forgetting the name of the width over here. Petal. Yeah, so there we go, petal. So length of the petal and width of the sepal. Now, based on this, if we want to plot something, I'm not going to put like the numbers over here, but it's like 0 point something, 0.1, 0.2 or something. So if I want to plot something over here, let me do a different color. Some of these will be over here. I mean, there is a scale over here. This might be like in centimeters because I think that's what it is measured in. So some of these things may appear over here. And we have the data, so we're plotting these. And if I change this color to something else, let's say yellow, and some of them might be over here. Okay. And maybe there is some other data also, let's say green. And some might be over here also. Now, all of these different categories or all of these different plots that I'm doing, they do represent a particular flower. So let's say that this, what is it, the orange one, so I'll probably select the orange color so that it's easier. So orange one, and I'm just gonna put some name over here randomly, is Virginica. So I'm just gonna say these orange dots that you see, these are Virginica. And we have the data, so we plotted it out. And for these green ones, we're gonna say this is versicolor. Versicolor. And for this one, we will say Setosa. Okay, Setosa. Okay, now we already have the data, we plotted it out. Maybe we have thousands and thousands of different, these plans. But what about if somebody puts a new, and we have a new reading, and what happened over here? And we have a new reading, and it's right here. I'm just going to put a star over here. So we want to now find out if this new thing that I put in, this new reading based on our other data set, is this Virginica, is this versicolor, or is this Setosa? So how can we find out that this new thing that we're trying to classify, which group does this or which category does this belong to? So this is where the k nearest neighbor comes into play, the algorithm for k nearest neighbor, k nearest neighbor, okay? And what k nearest neighbor basically says is that, first of all, we need to select k. What is k? Well, k is a number that you will select, and then you will find out that which of these, like your blue spot that you're trying to see if it's Virginica or is it versicolor or Setosa, if you say k is equals to, let's start with k is equals to 3, and always make sure that the k value that you select, I think by default is 5, but k you can select 3. And now you need to find out that who are those 3 elements, 3 dots closer to the blue dot that you're trying to classify. So if we take the distance, let's say that maybe this one is closer, definitely this one. And let's just say that if I select green over here, I'll select another green. Maybe there's a green dot right here. And now I'll select blue. And now these are the 3 closest one, right? Because k's value is 3. So these are the closest neighbors to your the thing that you want to classify. We don't know if this blue star, this new iris flower that you found somewhere, is this Setosa, Virginica, or versicolor. But when we put it on our graph, it looks closer to Virginica because 2 of the things are for Virginica. You can see it's near 2 of these, and 1 of them is near versicolor. And that's why we are saying k is equal to 3. So we will try to find a distance of 3 instead of 100. It's always a good idea to play around with k value. 3 means, well, you have to find the distance between 3 neighbors. And 5 is default. I would not put it like 10 or something, because then it will be a little bit messed up, because it might be closer to like 5 of them, and it can be really, it may not work correctly. And always try to make k the value which is even, not odd. sorry, odd, not even, because if you put it as the even number, then this can be 2, and then this can be 2. And then what is it? Is it Virginica, or is it Versicolor? All right, so let me go, and what if we change K to 5? So if I go over here, I don't want to delete anything, so I'll say 5. Okay, so let me see if there's a way to delete it. Erase. I don't think I can erase anything. Line width. Erase is different. Erase all. I don't want to erase all. Okay, that's fine. We'll just use a different color for the lines. Let's see if I can create this one. Okay, so when K is 5, we have to find out which one are 5 of them are closer. Okay, so this is close, this is close, but this distance and this distance, maybe this one is closer, and this one is also closer, and now we have 5. 1, 2, 3, 4, 5, right? And but blue star, the one that we're trying to classify, it's closer to which one? So if we look at this, well, this person gets 3, this only gets 2, so it's closer to this neighbor, so it's Virginica. And that is how you classify using K nearest neighbor. So the closest neighbor, the item that you want to classify becomes part of the neighbor, and it will be classified whatever that neighborhood is. Like in this case, is Virginica. All right. Any question regarding this?
Seems straightforward.
All right. So now let's go ahead and see that how we can do this in our code. So I'll go back. So here is our code. I'm going to move, and I'll have to refer to some code that I've already written. Okay. So we'll start with importing the same thing, which is pandas. So import pandas as ed. There we go. We also need to use scikit-learn. So from scikit-learn dot datasets import load iris. Just like load digits that we did yesterday, there is a function called load iris. And these are kind of like built in. Unfortunately, the Boston one for some reason now does not work. We already saw that, but at least we have a couple of data sets in there. Load iris is one of them, load digits is one of them. And now we can call this function. We can always see what it will return. So if I simply press on Shift Tab, I can see that load iris is a function. It takes some parameters, and let's see what it returns. Parameter return is X, Y. It returns data target. Okay, so it returns some sort of an object, you can see, and that object will contain all dictionary-like object, which will contain a lot of these different things, just like the digit. So I'll say iris. So it's going to be kind of like a dictionary. So if I say iris over here, you can see it's base load iris something something. We can just go ahead and say it. Give us a little bit more description. And there are a lot of different properties that are in iris. Okay, you can see a lot of different properties over here. Let's actually remove that. I don't think we need that part. Okay, so we have loaded all these iris, meaning we've called the load iris function that gives us this iris object. This particular object, you can see, it does contain properties like data, that is the actual data. It contains target, feature names. Okay, so that's interesting. What feature names does it have? And target names. Let's go ahead and check out target names, meaning iris, what kind of a target name, like a classification name, category names, this contains. Iris dot. I can do like this. I usually try to write it like this. You can use any way you want. Target name, Not scriptable. Okay.
You didn't have the parentheses next to load iris.
Oh, there we go. All right, so make sure that we do that. And okay, I don't want to do that. It's just an object, so I don't want to display it like that. Let's go ahead and display target name. Here we go. So you can see target names are kind of like the category names, and it's giving us an array with 3 different categories that we talked about. Setosa is now on index number 0. Versicolor is on index number 1, and Virginica is on index number 2 in that array. And so these are the target names. I think the other thing was, if I check it out, feature names, very important, because feature names is going to tell us what kind of features do we have. Features means like what kind of columns do we have? Well, eventually they will become columns. So we have sepal length, sepal width, petal length, petal width. So these are the features, and based on these features, we are eventually going to find out the target name. So based on the sepal length, width, petal length, width, we are going to classify that this particular flower with this sepal length, this sepal width, this petal length and petal width is either Setosa, Versicolor, or Virginica. All right. So before we do that, let's go ahead and I'm going to just refer to some of the code that I wrote. And what we're going to do is it's going to be a nice practice to create a data frame out of it. So PD, which is panda.dataframe, we are using this iris, whatever is in the data. I think if we put the data over here, let's go ahead and first put the data. If I say over here, iris, data. So data is just an array, 2-dimensional array. And you can actually see over here. Let's see what dimension it is. If it's a shape. Oh, sorry, it has 150 rows and it's 4 columns, so it's 4-dimensional array, not 2-dimensional array. All right. So we can use this and we can assign it to a data frame. So pd.dataframe iris, we're going to assign whatever is in the data, and the columns will be the feature names. So if I do run this, and now if I look at the data frame, you can see that we get all of this stuff. Right? So now we have this data frame, and that contains a lot of these different things. So we have basically converted all the iris stuff, meaning all the columns, now they're part of the data frame. And now it will be a little bit more easier to reason about and to use. All right, so we got that. We got the shape and everything. We can take a look at the target. Okay, and let's go ahead and see over here. Okay, so the next step would be we can also add a column over here, like a target column. And let's see what I'm doing over here. And we can assign the target value coming from iris. So if we go over here and look at the load iris, it does have a target names and it does have a target target property. The classification target, if as frame equal to true, target will be panda series. So let's go ahead and see what target it actually is. So if I say over here iris, target. So target is the actual index that's going to tell you whether that flower is Setosa, Versicolor, or Virginica. So you see this, all these zeros, these are 50 zeros. This is basically saying that the first 50 are Setosa, the next 50 right here are Versicolor, and the last 50, so there are 150 total, the last 50 are Virginica. So that's what it is actually saying. So what we can do is we can say data frame, go ahead and create a column called target and assign the value of the target column. And now if I say df, I have the target column, and if I print out the whole thing, you can see some of them are 0, some of them are 2, some of them are in the middle, they're 1. So basically we found out that in this particular data set, 0 to 50, index 0 to 50 are Setosa, 51 to 99 or 51 to 100 or something are versicolor, and the remaining 50 are virginica. That's how it is arranged actually. So we can actually see it over here also, their targets. All right. Now it will be a good idea if you're trying to plot something, it will be a good idea to kind of like create these separate groups. So we can say df0, and df0 means the data frame 0, and that will contain from 0 to 50. So I can say data frame 0 to 50. And if I print out, well, the length of this, df0, obviously it's going to be 50. So what we did is we took this data frame, which contained 150, and we created a new variable called df0 that only contains 50. And we're just doing that so that we can just draw it out. I mean, you'll see that we're not doing it for anything else. So this will be from 51 to 100 or something. All right. And after we do that, you can see over here, 3 to, okay, we printed it out 50 to 100. Then we can kind of like try to draw it out. And you can do df, the remaining one, which is df2, df, which is going to be 100. Let's say 101. Let's see over here. I think 50, 50, and then 100 to 150. So we're just doing that so we can kind of like draw it out. And in order to draw it out, we can import matplotlib.pyplot as plt. We can also probably do the inline part, matplotlib inline, so we can actually draw it in Jupyter Notebook. All right. So how can we plot this? We can do kind of like a scatter plot, plt.scatter. And let's see what we can do. df0 and df1. So we can draw both of them, df0 and df1. There we go. And that's how it looks like. It's always a good idea to kind of like plot it out, although we are not really going to be using the plot anyways, but this is how it looks like when we plot. So this means that if you are trying to classify something like a new flower, and that flower is kind of like over here, right there, then and k is equals to 5, which is by default, then how would you classify it? Well, you have to find the distance between the closest things that you can find. Distance between this, distance between this, distance between this, this, and this, and even this. This might be too far, so we just automatically going to ignore that. And when you find the distance, you will eventually find out that, well, it belongs to this blue group because it's closer to this. And that particular flower that you're trying to classify will be the same as this blue group that's over here, which can be anything. All right. Any questions at this point?
Not yet. Not so far.
All right. Yeah. So we haven't really trained anything. We're just trying to see how it looks like. df0, df1, df2. I mean, with just used for plotting these things. If we want to, and we do want to train it, so the first thing we're going to import will be, I think it's from sklearn, right? From sklearn dot, what is it called? Model selection. Model selection. Import train test split. So it's a good idea to import train test split because we want to train using 80% of the training data, and we want to test with the 20%. Now, this can change depending on how much data you have. You can do 90-10, 70-30, 80-20. I think 80-20 is kind of like common, so that's why I'm going with that. All right. Now we can say train test split, and we need to pass in the value of X and the value of Y. So what will be the value of those things? If we look over here, X can be all the columns, but without the target column. So currently we don't really have anything. So if I say over here, df, you can see over here in the df, which is the data frame we created, it has all the columns that we need: sepal length, sepal width, petal length, petal width, and target. Target is not the one that we need because target is the one that we want to categorize. That's basically our resulting column that we want to find out. So we can say X equals to df, which is the data frame you see below, dot drop the column, only one column you're going to drop, target, and it will be on the axis, which will be column. Now this drop, since I'm not putting in place true, this means that this drop is going to return a brand new data frame and give it to the variable X. And that is perfectly fine. I don't really want to mess around with df. It's just going to return me a brand new one. And the Y will be the thing that we are trying to find out, which will be the target itself. So now we have the X and the Y. Y is the thing that we want to predict using the feature columns, which is in X. And now we can do train test split. Train test split, X, Y. This is going to return us X train, X test, Y train, and Y test. All right. So that part is kind of like the same. On the X-axis, we always send the features. And on the Y-axis, we always send the thing that we're trying to predict, like the target. Is it 0, meaning Setosa? Is it 1, which is versicolor? Or is it 2, Virginica? So that's what the target that we're trying to find out.
I have a quick question.
Mm-hmm.
So in this scenario, the data frame is like in an order where the first 50 are one type of flower, the second 50 are another. So when you take the 80% for training, is it taking it just in order from like 0 to whatever is 80%, or does it grab randomly so that
randomly
we aren't missing?
It grabs,
okay.
Yeah, so it grabs randomly. Yeah.
Perfect. Okay, cool.
Yep. Yep. So now we have, I forgot to say test size. So now I'm putting test size of 0.2, which is 20%, and 80% will be used for training. You can always tell because if I say length of X train, that is 120. And if I say X test, that should be much less, which is 20% of 120 is 30. So it's whatever, 20% of that. Okay, so once we have done the testing, the next step would be to use some sort of algorithm to predict this. And looking at these diagrams, we found out that since it's a classification problem, we can use either logistic regression, which we did yesterday, or we cannot use linear regression because linear regression was more about like predicting the price of something, like an actual number that you predict. Over here, we are not predicting a price or anything. We're just predicting a category. Is this versicolor? I mean, it's, well, if I put something over here, is this going to be setosa, versicolor, or virginica? What is this? So we have to classify on known categories, the categories that we already know, which is over here. Kind of like if somebody give you a picture of a dog and a cat, and you have to, and then you have to classify, well, this picture is of a cat or a dog. So you already have a predefined categories, cat and dog. You're not going to say, oh, it's a rabbit or anything like that. So we have to create some sort of a model, and that is where k nearest neighbors come into play. So k nearest neighbors. The good thing is that all of these scikit-learn stuff, you can see the k nearest neighbors classifier. Easily we can import it, just like what we did for logistic and linear regression, logistic regression and linear models. So we can easily import k nearest neighbor. All right. Next, we can go ahead and create instance, meaning an object of this. But k nearest neighbor, if you look at the documentation, it does take a lot of different parameters, which are over here, but one of them it takes is nearest neighbor. That is the value of k. So by default, you can see it's already 5. You can leave it there if you want to. I'm going to go ahead and change it to 3. It can be 3, 5, 7. Try to use an odd number, but don't try to use so big numbers because then it will be a little bit messed up. So we're going to go ahead and save it 3. Okay, and then the other part is kind of like the same as we have been doing before. Well, we have to use fit. Fit is used for training. So how do we train it? Well, we're going to pass an X train and Y train. Okay, pretty quick to train, only 120 rows anyways. And now we can do knn dot predict. And over here, we're going to be passing in the X test. All right. And I think in this, we pass in the features. Let's go ahead and see. And this is what it actually returns us. If we pass in the X test, is telling us, I guess in the test, is telling us that 2, meaning the first one is virginica. This is versicolor, and then you have this one, which is, what is it called? Let's see, setosa. So that is what it is predicting now. All right, let's see what X test contains. Yeah, so basically it's telling us that this one is this one is this one is this, and then this is something different. So we are able to test it. We're able to see the result. What if we say score, knn dot score on X test and Y test? Okay, so score is coming out to be like 96%. I actually thought it's going to be much higher than that. We can change k to 5 and try to train these things again. And let's see the score. Score still remains that. What if we do like really high, 25? Now I'm thinking that the score should go down, but it's still the same. So not sure why the score is not going down. Let me actually double check over here. Yeah, but in the last time that I did it, the score was coming out to be 100%, 1.0. So X test, Y test, somehow it's still coming out to be 96. All right. I don't think it should be coming out 96 because we're putting like 25 over here. Unless I made a mistake somewhere, but that's what it shows right now. So we'll just say 3, I guess, over here. X train, Y train, nearest 3, predict. Yeah, still 96. I'm not sure why it's 96. I thought it's going to be a little bit, it should be like 1, not 96. But that's what it is coming out to be. All right. So this one, so we today learn about k-nearest classifier. This is used to classify things for predefined categories. So just like logistic regression, which is to use to classify, you can also use k-nearest neighbor classifier to classify these things. All right. Any questions?
So I forgot based on the examples we did yesterday, with logistic regression, can you only compare or have 2 different targets, or can you have more than 2 targets for logistic?
I think usually I've worked with mostly with 2 different targets with logistic regression. But yes, you should be able to do multiple targets also with logistic regression. So whatever the k-nearest neighbor can do, the logistic regression should also be able to do. I don't think it's only binary like 0, 1. I think it can do multiple things. It becomes like what kind of a graph is being created, and what can you do in those cases. But actually, let me double check it before I give you any wrong answer. Let's see over here. So we're talking about the logistic regression in scikit-learn and can do 3 or more classification of items or something. Can be used for binary classification as well as multi-class classification. For multi-class classification, when you have more than 2 classes, scikit-learn logistic regression implements some other strategy, and so it is able to do that. Yeah, and then I think they wrote the code for it, which is kind of cool. They wrote all the code for doing all of this, which is similar code that we are writing. Make classification, sample features, number of classes 3. Yeah, so number of classes 3 means there are 3 things. Not sure what they're trying to classify, but you can classify multiple things. Yeah. All right. All right. Any other questions?
No questions.
Let's see. And you said you were looking into that, what is that called? The SQL stuff?
Yeah.
Okay. All right, let's see. Yeah, some of the SQL stuff, I don't think that you have any SQL stuff in your modules, right? I mean, let me double check it over here. I mean, you have something in SQL where you have to do the quizzes part of it, which, yeah, make sure that you do that. But if I go to modules, and this module, yeah.
Yeah, for module 2, it's mostly SQL.
Yeah. But if we go to the lab assignment, those are a little bit different, I think.
Oh yeah, the lab assignment is different.
Okay.
For whatever reason, like the interactive assignments are all SQL, and then the lab assignment is just that what you have up there.
Yeah. Okay. Yeah, I'm not sure why they have the SQL stuff. I mean, I don't know if I don't really see it fitting in correctly, but I mean fitting correctly. But that's what they have. But let's see. So module 2, May 7th, which I believe is today. So make sure that you are completing all the, all the work, all the assignments and quizzes and all that. And for the GitHub GitHub stuff, those are just ungraded stuff. Just whenever you complete it, just send me link or something, and that should be more than enough. I can double check it. And this is the module 3, which is going to be starting tomorrow. So it's more about visualization. The good thing is that we already covered some parts of it, like matplotlib. So let me go through it. Instructor live. I think it's just okay. Discussion stuff. Discussion board. I'm trying to get to the labs. I think I should have just clicked on there. And then we have assignment. There we go, lab. So you'll see that for module 3, it's visualizing data. And I think mostly they are using matplotlib right there. But somewhere they might be mentioning Seaborn also. Oh, here we go, Seaborn. Seaborn is another library for plotting graphs. It does have some graph, I think it's called compromised graph or something, which is used for KNN and classification graph, like how many times it was correct and how many times it was not correct kind of thing. But you may have to install Seaborn also for your Jupyter. Well, I guess if you're doing it over here, you don't have to do anything. You just have to do it over here, which is already installed. So that's good. Yeah, so Seaborn is another library for creating graphs, kind of like Matplotlib, but I think it has like different kind of graphs. So module 3, interactive, you can see interactive assignments, visualizing best practices, tools for visualizing, and all that. And then the important part, which are the labs. And both of them are for visualizing the data using charts and all that stuff. All right. You can see over here. Yeah. All right. Any other questions? How are you finding this working over here? I think my biggest issue when working with these embedded things was that I wasn't able to see the data frame, like if I wanted to print out, but the solution was just to comment out all of this stuff, I guess, and then do it or copy it out, I guess.
Yeah, so I'm used to working in like an IDE, and so or like I like Jupyter as well. Jupyter is pretty nice based on my experience with it in the class. And so I basically what I do is if you've looked at my results, I typically just submit just this if I need to see the results, just like you would in the IDE, you would just run it to see results and do like a trial and error sort of thing. So that's how I go about it. But I mean, it's a little, because it's in there, it's a little limited. And I don't really like the develop mode because how you do the inputs.
Oh, okay.
Yeah, you have to put the inputs in there, and it's just kind of disconnected, in my opinion. So I just typically will submit it however many times I need to see my results, or like if I want to print something, I'll just do a print in there and then submit it to see the print.
Submit, like the submit mode.
Yeah, like I'll just straight up submit it for grading, and I don't really care about like how many submissions as long as I get it to 100%.
Oh, okay.
If you see what I'm saying, like
so if I print hello world over here, and if I'm in the develop mode and I run it, I won't be able to see this because the rest of the code has some issues we can see over here.
Right. I mean, I could also just comment out, but that's kind of, considering, it's not an IDE, it's kind of tedious commenting stuff out because you can't do like a shortcut for commenting. So the quickest way to go about it is to go into submit mode and just print whatever you want.
Submit for grading?
Exactly. So yeah,
Okay.
like
Let me
and,
see
and
what
that's why I
happens.
said, like, if you were to look at my results, I'll have like 5 or 10 submissions, however long it's, because
Okay.
some of those submissions are me looking at, trying to test stuff out and like look at some of the results in order to
Hmm.
get to the correct answer.
Oh, okay, okay. Because it's still, even in the submit mode, if I try to print, like if I want to execute line number 5, it never really shows me, right? Like hello world, like it's never here.
Oh, well, I like get it to run. Like, so I mean, also what I could do is I could just have everything technically installed in a IDE. Like I could
Okay,
install or all of this and move it to IDE, but I haven't done that. All I do is I'll get it to run and I'll comment out whatever I need to comment out and get
okay.
it to run. And then, but typically, the reason I typically do it in submit mode is because typically it'll have inputs that
Hmm.
it auto generates. And instead of like actually coding
Hmm.
out my own inputs, I'll just use the inputs that they give us. So that's
Oh,
why I
okay.
typically do it in submit mode. Hopefully, you understand where I'm going with that.
Yeah, yeah, yeah. Okay, got it. Got it. Yeah, I mean, I was thinking like if somebody was like copying all of this, I guess you can do it. I guess you can copy all of this into and paste it in Jupyter Notebook. But I guess in this case, you do need to install Seaborn. Um, yeah, if I go to my Jupyter Notebook over here, oh, I think I closed it. Okay. This one, I think. This is the one that we were working on. Okay. So if I go over here, and even if I say import Seaborn as SB, Seaborn, yeah, so you can see that Seaborn, we didn't really install it. So it's going to give us this kind of a problem. Um, what was the way to install it? Now I have to look it up. I think it was npm install Seaborn or something like that. Let's see. If I stop this, which is Control C, yes, and conda env list. I'm currently on the correct one, which is this one. I wonder if it's like conda install Seaborn. I think this is the one. Okay, it's doing something at least. Packages is fine. So conda installs Seaborn. And I guess it is installed, but now let's go ahead and run Jupyter Notebook. Hopefully I don't have to install it again and again. I think it's just installed one time and it's done. And let's see if this runs. Okay, let's scroll down at the bottom. I thought I had saved it, but import Seaborn as Seaborn. Okay, now it didn't give me error. So now it looks like it's working. Because
It worked.
last time when I did that, it was giving me error. Okay.
Yeah, I'll go ahead and
So
do that right now, see if it works for me.
okay, and let me name this something. Class work K nearest neighbor. I think this is the old one. Close this, I guess. And class work one compress. Okay, nearest neighbor. Okay, so the one that we just did, you will have access to it. K nearest neighbor in the chat, so you can download it from there. Okay. All right. Any other questions before we wrap up?
1 second.
Mhm. And tomorrow we can look at gradient descent.
Okay, sorry, I was getting that downloaded. No, I think I'm good.
Okay. All right. So let's see. Tomorrow I'll try to do gradient descent, or I'll see what else or what other stuff we can do. Just make sure that the module one, module two stuff, assignments, whatever, quizzes, whatever you have, like interactive assignments and labs, make sure you submit those things. And we're going to resume tomorrow. And you can download the code from the chat, the one that we just did.
Okay, sweet. Thank you.
All right. Then I will see you tomorrow.
All right, see you tomorrow. Thanks.
All right.